Okay, this is 9.1. We're talking about ellipses. Um, what is an ellipse? It's kind of like a circle, but not really. Um, I think a circle is an ellipse. It's just it's not elongated. So ellipses, you think of it like a football. It's kind of like an ellipse, that sort of shape. I'll show you here in a second. So we begin with this nice definition. Um, it's a set of all points p sub 1 such that, or rather just p, set of all points such that, um, and we sort of need a picture to define it. Okay, so we have this object, like I said, it's kind of like a football. And inside the object are 2 points called foci. Okay, so there's a foci 1 and a foci 2. Okay. The ellipse is a set of all points x comma y. So here's this point P I was talking about. Set of all points x comma y such that the distance from this point to the first focus plus the distance from this point to the second focus is equal to a fixed constant. Okay, so algebraically writing that, we'll have P, the distance from P to focus 1 plus the distance from P to focus 2 is equal to some fixed constant, and the fixed constant is actually 2 times A. So what is A? Well, A is going to be the distance from the center to the vertex of the ellipse. So we're going to call this point the vertex. And traditionally, it's given the coordinate a comma 0. Okay, on the other end, then, this vertex will be at the point negative a comma 0. And then the foci are given coordinates with the letter C. So this point here is C comma 0. And then this point here is negative C comma 0. These points on the top and bottom of what they're going to call the minor axis. So this long distance is the major axis. And then the shorter distance here is the minor axis. Okay, so the points on the minor axis, which I sometimes call the minor vertices, are given the coordinate 0b. Okay, so the little letter b, 0b, and then of course down here will be 0, negative b. Okay, so b is always going to be less than a. And what else? The formula for it as it sits now with the center at 0, 0 is going to be x squared plus y squared, and the denominators here will have this a and the b from the graph, and this will equal 1, and this should be b squared. Okay. Okay, one other detail that we could throw into all of this information is that the C value, it can be written in terms of A and B. And so in particular, you can think of these P places, these P points as being the result of taking a piece of string from F1 to F2. So you have a loose piece of string from here, and then there's little tacks at F1 and F2. So you tack in the string, and then you push it out so it's taut. Okay, so I have 2 tacks here and a piece of string, and then I take the piece of string and push it as far as I can. Okay, and then if you just scribbled out the result, what you would end up with is this ellipse. So you can think of this P point as being anywhere on the ellipse, and in particular, if you put it at the top. So if I redrew my ellipse and then position this P guy here at the top of the ellipse. So it's actually at position 0, comma b now. And then I have my little remnants of the string going to the foci. I can sort of figure out what the C value is. So the C value, if you look up here, is just the distance from here to here. Okay, so this would be your C value. The B value is the distance from here to here. The distance from here to here is B. Okay, so that's what B is. And then you see, well, hey, this is a right triangle. And I also know that the entire length of the string is 2a. So if you add this distance plus this distance, you get 2a. All right, so this distance to this distance is 2a, and it's being perfectly bisected, so I can actually say that this distance here is just a. And then you can solve for c using the Pythagorean theorem. So you would have, in particular, b squared plus c squared is equal to a squared. And then we want to solve for c, so you'd have c squared is equal to a squared minus b squared. And then finally, c is equal to the square root of a squared minus b squared. Okay. So that becomes another formula, which is very important. It's one of the first things you find when you go to graph the ellipse. Okay, so you can have different orientations of ellipses. You can actually rotate the ellipse on any angle you want. In particular, though, in this book, we'll just look at the ellipse where the major axis is on the x-axis or parallel to the x-axis, and then the minor axis is on the y-axis or parallel to the y-axis. Okay. So let's look at the other orientation then. And now we'll actually just put the foci on the y-axis. These will be your vertices. We use the same letters, it's just now the points are reversed. In other words, this point, instead of C0, you have 0C. And then up here, instead of 0B, it's 0A, right? And then the minor vertices are out here. So this guy right here will be at B0. And then this guy, of course, is negative B0. And then down here, we have 0, negative C, and then 0, negative A. Okay, so this is the same deal. The formula changes a little bit in this new orientation. The A value now is associated with the Y term. So you would have x squared all over instead of a squared like we did before. Now you have x squared over b squared and then plus y squared all over a squared equals 1. In general, what you do is just look for the bigger number, and the bigger number is going to be the a value because of this inequality here. So in general, when you're dealing with this formula, just look for the bigger number, and that's the a value. Okay. Okay, so this is our sort of standard form, and right now we're oriented at the origin. In a couple minutes, we'll look at shifted versions of these guys. We'll go through the same kind of development. But for now, let's just play around a little bit with some of the homework exercises and see how that goes. Okay. So first, they want you to graph the ellipse and locate the foci. So this is problem 4. We have x squared over 16 plus y squared over 49, and that equals 1. Okay, so when you go to graph these things, you want to begin by getting your a, b, and c value. The center will also be important later on, so we might as well note that. For these guys, the center is just 0, 0. Right, so now I want my a, b, and c value. So the a value you'll get from the bigger number. So here are 16 and 49. This is going to give you the a value. And it's not 49. A is not 49. It's the square root of 49. Okay. A squared is 49. So A is 7. The B value then, square root of 16, so that'll be 4. And then the C value you get using the formula we just derived from the Pythagorean theorem. It'll be A squared minus B squared. Did I screw that up? I think I screwed it up in my notes. All right, well, there's that. Let's get this real quick. Oh, no, I didn't screw it up in my notes. Something weird happened there, though. Right, so root 33, we're going to be graphing, so it's best to get a nice decimal approximation for these things. And we get 5.7 for our C value. We can go ahead and graph this thing now. Because the A value is associated with the Y term, we have the major axis parallel, or well, on the Y-axis in this case. So I'm going to have to go up 7, 2, 3, 4, 5, 6, 7. That'll give me my A, my vertex, really. So these are my vertices I'm talking about. So the vertex, first one, 0, 7. And then the second one, 1, 2, 3, 4, 5, 6, 7, 0, negative 7. So it's in this case, it's okay to write 0 plus or minus 7. Okay. In general, don't do that. Like when you're solving systems of nonlinear equations, you wouldn't want to write it with a bunch of plus and minuses. I saw some people do that, like on the test, like they put, if this was something other than 0, plus or minus 3, plus or minus 7, that doesn't really make it clear as to what your answer is. But in this case, it's at least seems well defined. You have 0, it's either plus 7 or 0 minus 7. Okay, so that's fine in this context. Let's get the B values now. So 1, 2, 3, 4, 1, 2, 3, 4. And put the minor vertices out there. So if you want to kind of give them, I'll put V sub little m for minor. So in this case, it'll be plus or minus 4, comma 0. We also need the foci, so plus or minus root 33 or 5.7. 1, 2, 3, 4, 5.7. 1, 2, 3, 4, 5.7. So it's 0 plus or minus root 33. Okay, and then finally just connect the vertices and you have your graph. Okay. Okay, let's look at number 11. Okay, so this guy is not in a nice form. We had to get the y squared over first, so x squared plus 4y squared is 1. And then secondly, I need to get this rewritten as x squared over a squared, and you could pretend at this point it's x squared over 1, okay? And then plus y squared over something. Okay? So instead of writing 4y squared, an equivalent way of writing that would be 1 all over, well, an equivalent way of writing 4. So if we look up here, 4 is the same as 1 all over 1 over 4. Okay, these guys are equivalent ways of writing the same number. So we can rewrite 4y squared as just y squared all over 1/4. Okay. So our a value is the square root of 1, which of course is 1. It's the bigger number. So 1 is bigger than 1/4, so therefore that must be our a squared. Then b is the square root of 1/4. Okay, so the square root of 1/4 is 1/2. And then our c value will be the square root of 1 minus 1/4, which will be square root of 3 all over 4. Just 4/4 minus 1/4 is 3/4. And then it'll be square root of 3 over 2. Let's get a nice decimal going. So that's approximately 0.866. And now we can go to our graph. Okay, so this time the bigger number is on with the x term, so that's going to be where our axis, our major axis is. So it's going to be oriented with the longer part on this axis. So I'll go out to just put 1 here, and I'll do the same thing on the y-axis, -1. Okay. So the vertices will be at 1, 0, and then -1, 0. Okay, so the vertices at plus or minus 1, 0. And then the minor vertices will be at 0, 1/2, and then 0, -1/2. And then the foci points will be at plus or minus 0.866. Okay, so we'll go over here or over here, and then connect your vertices, and you're done. Okay, so this is, plotting. The next one is kind of like a puzzle question. They give you some information. You have to create the equation based off the information. So let's take a look. So here's 28, and they're giving us the foci. All right, 0, plus minus 3. And then they give us the vertices are at 0, plus minus 4. Okay. So for the equation, which is what we're after, we would have to have the A and the B values, right? This has given me the C value, and this is giving me the A value. Okay, so I can write A is 4, C is 3, and then all I have to do is figure out the B value. So if you remember how it went from the Pythagorean theorem, A squared plus B squared is equal to, or rather, how did that go? So maybe I have to draw a little picture to remind myself. Okay, so this height was B, this was C, and then this was A. So I have A and C, I want to get B, so it's going to be B equals square root of A squared minus C squared. Okay, if you don't see that, you write out the Pythagorean theorem. So we have C squared, the legs squared, summed, equals A squared. And then what are we trying to solve for? We're trying to get B by itself. So you just subtract the C squared, and then take the square root. This time we don't need the plus or minus. Okay, so anyways, getting back to here, then we can find B by doing a substitution into this formula. So they'll have 16 minus 9, which is square root of 7. Okay. So now we can plop everything into our formula, and we have x squared all over something plus y squared all over something equals 1. The somethings then, well, in this orientation with the vertices on the y-axis, we know the bigger number, the A number, has to go with the y squared. Okay, so in particular, it's not 4, it's 4 squared. It's a 16 that we want to put here. And then over here, we're putting the b squared, so 7. Okay, and that's it. So there's some tricky problems like that in the book. They're really just puzzle questions. Okay, let's move on to the standard form of the ellipse, this time not centered at the origin. So we could say the vertex is HK. And the best way to get a handle on this is to remember your circle formula, which is kind of basically an ellipse formula with the denominator on the other side. So recall if you had x squared plus y squared, equals r squared. That was our circle formula. Then we said the shifted version of this would be x squared plus, oh sorry, so x minus h squared plus y minus k squared equals r squared. Okay. So look at this. This is very, very similar to the ellipse formula. It's just that the a and the b are the same in these cases. If you divide both sides by r squared, you get this formula. And then the c value, of course, will be then 0. So that's kind of interesting, right? So r squared minus r squared, the c value is 0. So a circle is just an ellipse such that the c value is 0. Okay. So anyways, if you remember this form of the circle, it's kind of like what we want to do with the ellipse. Okay? So we want to go from our standard form centered at the origin, which for the ellipse was x squared all over a squared plus y squared all over b squared equals 1. And now, so this is with center at 0, 0. And now pull this kind of transformation. Okay, so we'll have now x minus h squared all over a squared plus y minus k squared all over b squared equals 1. And the center here is at h comma k. Okay. So it looks like a very intense, complicated formula, but it's not a big deal if you already understand how the circles work. It's just a variation on that theme. Okay. Okay, so we want to investigate this a little bit and see how this goes, right? So let's sort of draw up the pictures first off. So again, there's going to be two orientations. One with, so this will be our center h comma k here. There'll be two orientations, one where the major axis is parallel to the y-axis, okay, and that'll be this case. And then one case where the major axis is parallel to the y-axis. Okay. So again, the main thing that's going to change here for us is you just kind of sneak in an h and a k. And then our formula for our foci and vertices. So the vertex formula, what you're doing is moving back and forth by this a value, right? So if you start here at h comma k, in order to get to the vertex, what you're doing is adding a to the h coordinate. So it'll look like this, h plus or minus a comma k. Okay, because you're just starting here and then you're going this way or this way. Okay. For the focus, for the minor axis vertices, you're going to go up and down. So what you're doing is manipulating the k value, the height value. So it'll be h comma k plus or minus this b, and this should be a b squared, sorry. Plus or minus b. Okay. And then the foci, you'll have the same for the vertex. So these are kind of similar because the points are on the same sort of horizontal line. Okay, so this will be h plus or minus b, c then, comma k. And of course the c formula is the same. C is the square root of a squared minus b squared. Okay, and of course also a will always be greater than b for these kinds of problems. Let's look at the other orientation then. So maybe we have our center in the first quadrant, and then our vertices, our foci, and then our minor vertices. Okay. And so this time, the bigger value, the a value, will be associated with the y term. So I'll have y minus k squared over a squared, and then plus x minus h squared all over b squared equals 1. And then to get to the vertices, instead of going left and right, you're going up and down. So what you do is manipulate the y-coordinate of the center in order to get to those new points. So plus or minus A for that. And then the foci is the same deal, except you're going plus or minus C. And then for the minor vertices, of course, you're manipulating the x-coordinate of the center. So you're going H plus or minus B, comma, K. Okay, right. So let's try to do a couple of these graphs, and then there's kind of a complete the square version of this that we have to worry about, which we saw before when we were dealing with circles, which you've probably forgotten by now, but I'll show you again. So anyways, what we want to do is graph these things, and basically I'll want to see your vertex, your foci, and your minor vertices, and then plot them all just like we did up here. Okay, so let's take a look at number 40. Excuse me, x minus 3 squared plus 9 times y plus 2 squared is 18. Okay. Need to get it into my standard form, so I'm going to divide both sides by 18. I get x minus 3 squared all over 18 plus 9 all over y plus 2 squared all over 18 is 1. You could simplify. 9 over 18 is the same as 1 over 2. Okay, so let's rewrite that. X minus 3 squared all over 18 plus y plus 2 squared all over 2 is 1. Right, now let's get our a, b, and c values. So a is going to be the bigger of the two. And here we have a squared is 18, so a is the square root of 18, which of course is 3 root 2. Let's get a nice approximation for that guy. 4.24. The b value then is the square root of 2, which is about 1.41. And then the c value is the square root of 18 minus 2, which of course is just 16, and the square root of 16 is 4. Okay. So let's go over here and start working. The center, we need to know that, of course. So the center is going to be from these two values, the 3 and negative 2. So the center is 3, negative 2. So we're going to be working mostly in the fourth quadrant. It's important to note that so you can adjust your XY plane accordingly. So I have not done a very good job of that. But and then the vertices. So let's first get the center. So 1, 2, 3, negative 2. Okay, and then to get the major vertices, I'm going parallel to the x-axis, and I'm manipulating the center by 4.24. So what does that mean? I'm going 1, 2, 3, 4 in this direction, and then 1, 2, 3, 4 in this direction, 4.2 something, so it's a little over. And then I'm going to go 1.41 up and down, so 1.41, 1.41. I need the c value, so that would be a 4. 1, 2, 3, 4. 1, 2, 3, 4. It's over here. And then you can connect the dots, and you have your picture. Let me go ahead and get the actual coordinates for those points. So again, what we're doing is manipulating the h and the k. And for the vertices, I'm manipulating the x-coordinate. So I'm going left x and then right x. So right x and then left x. So it's going to be 3 plus or minus square root 18, comma, negative 2. For the foci, it's 3 plus or minus, we went 3 plus or minus the 4 distance, comma, negative 2. And then for the minor vertices, I went up and down. So you manipulated the y-coordinate by root 2. Okay. And that's all you need to show, and then you can go on to the next problem. Okay, so let's go on to the next problem. This is 44 now, so 44. we have x minus 4 squared all over 4 plus y squared over 25 equals 1. Okay, so the a value this time is with the y coordinate. So, and we'll need our center as well here, but let's get the a, b, and c first. So a is square root of 25, which is 5. B is the square root of 4, which is 2. So they're giving us some nice numbers to work with. C is the square root of 25 minus 4, square root 21, and the approximation 4.58-ish. Okay, so the center extracting from this information is 4. And then if you don't see anything, it's just 0, right? So y squared is the same as y minus 0 squared, so it's just 0. So we're going to mainly be in or on the positive x arm. 4, so right here. Okay, so let's start getting our points. So the vertex, we're going left and right by 5. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Okay, went a little off the page there. For the foci, you're going left and right by 4.58. So for the foci, 4 plus or minus, it was square root 21 originally, 0. So 1, 2, 3, 4.58, 1, 2, 3, 4.58. And then finally for the minor vertices, we're going up and down. So it'll be 4, 0 plus or minus 2. So 1, 2, and then 1, 2. And then connect your dots. And you got it. Whoops, I totally did that wrong. Sorry about that. What is wrong? Well, obviously it's the wrong orientation. That big value is associated with the. So let's try that again. Sorry about that. So it's 1, 2, 3, 4, 0. So the vertices will be found by manipulating the y coordinate. So the major axis will be parallel to the y-axis. So the vertices, we have, let's see, what is it, 4, 0 plus or minus 5. So go up 1, 2, 3, 4, 5, and then down 5, 1, 2, 3, 4, 5. And then the foci, you're manipulating the y-coordinate with the c value. So 0 plus or minus square root 21. So that's 4.58, really close to the vertex in either direction. And then the minor vertices, you're moving in the x direction, so shift the x coordinate of the vertex plus or minus 2. So 1, 2, 1, 2. And then connect. Sorry about that. So there we go. All right, so the last one is this completing the square problem. And I think we had to do this back when we were dealing with parabolas and trying to get them into that vertex kind of form. I think we also saw them when we were working with circles. So we would have 9x squared plus 16y squared minus 18x plus 64y minus 71 is 0. So the deal is you want to get it into the standard form that we've been dealing with. This kind of look, looking like that. So what you're going to do is collect the x terms together, 9x squared minus 18x, and then the y terms, collect those together, 16y squared plus 64y. On the other side, we're putting the constant terms, so right now we have 71. Okay. We want to complete the square on this guy and this guy. One tidbit about completing the square, you need a leading coefficient of 1 to do that. Right? So the first thing we have to do here is factor out. So we factor 9 out of these two terms, and we'll have x squared minus 2x, and then we need to add something in to complete the square. And then likewise, I need the factor out 16 here, so I'll have y squared plus 4y, and then plus some extra bit. And then on the other side, if you are adding things in here, you also need to add things in here. So it would be plus something plus something. Okay. So what is that something? Well, you have to go back to the magic number b all over 2 squared. So the b value is from this. So in this case, it'll be negative 2 all over 2 squared. So negative 2 over 2 is negative 1. Negative 1 squared is 1. So I'm adding 1 inside. And technically, you've not added in 1. You've added in 9 times 1. Okay, so if you were to distribute this out, you would see that. You don't have 1 on this side. You've added in a 9. So on the other side, to keep things in balance, you can't add in 1. You actually have to add in 9. Okay, then the other guy, b, this case is 4 all over 2 squared. So 4 over 2 is 2, and then 2 squared is 4. So I'm adding a 4 in here, and again, you've not just added 4, you've added 16 times 4. In other words, 64 to the other side. Okay. So let's go ahead now and factor. So I have 9 times x minus 1 squared plus 16 times y plus 2 squared, and then that equals 144. Okay, so I'm getting closer to my objective. Divide both sides by 144. On this side, 9 over 144 will be 1 over 16, same as 1 over 16. And then 16 all over 144 is the same as 1 over 9. Okay. And then get your ABC values. So the A is the bigger one. So this one will be oriented with the major axis parallel to the x-axis. So A will be 4. B will be 3. And then our C value will be the square root of 16 minus 9. In other words, square root 7, which is approximately 2.65. Okay. Okay. The center then for our ellipse will be at 1, negative 2. Okay, so we can start thinking about our graph. So 1 and then down 2. To get to the vertices, you're using the A value, and because the bigger number is with the x term, you're going horizontal to the x-axis, okay, or parallel to the x-axis rather. So I'm going back and forth by 4, 2, 3, 4, and then 1, 2, 3, 4. Use the A value to move, and so our vertex will be at 1 plus or minus 4, negative 2. And then the foci, again, you're going in the x direction, 1 plus or minus root 7, negative 2. So root 7 is 2.65, 1, 2.65, 1, 2.65. And then finally, our minor vertices, we're moving up and down, so I'm going to be adding things to the y-coordinate. In particular, we're going up and down by 3. So 1, 2, 3, and then 1, 2, 3, and that should be it. Okay, so that's our introduction to ellipses.